Good morning, class. Today we're starting chapter 8. Lesson 8, or chapter 8 is about the metric system, and we're going to introduce and maybe hopefully reintroduce some of the aspects of the metric system that you need to pay attention to. So let's begin. First things, metric system is one of several types of measuring systems. The first one here, SI system, System International de Unitas, is commonly referred to as the metric system. In Greek, metron means to measure. We also have the U.S. customary system, and the U.S. uses both. Metric system is predominantly used in auto, construction, farm equipment, and bottling industries, as well as health-related industries. Whereas other industries are starting to convert to the metric system, it is a slow process. When I was your guys' age, they kept saying how, by the time you guys get to college, we'll be all using the metric system. That is not the case still. So let's talk a little bit more about some advantages, too. So the advantages of the SI, or the standard units, is its worldwide accepted standard of measurement. All nations that participate in international trade have the metric system as the official system of measurement. So we can have one way to measure materials throughout. That way everybody's on the same page. There's only one basic unit of measurement for each physical quantity. Length in SI is measured in meters. Customary measurements, we could do inch, we could do feet, we could do yards, we could do miles. There's lots of different ways to measure customary length style. And the SI unit is based on the number 10, and so we don't really need to use fractions very often. If you've ever helped in the shop class or done measurements on your own with a standard customary tape measure here in the U.S., you may have had to measure something that's 5 3/4 of an inch, whereas in the metric system it would just be a number. So hopefully it works a little smoother. Here are some of the basic terms you'll come across as we get into this work. Meter, used to measure length. About the height from the floor to the doorknob, that's about a meter. Kilogram is used to measure mass, not weight. There's a difference. Kilograms a little more than 2 pounds. Grams are used to measure very small amounts. Nickel has a mass of about 5 grams. So very small amounts, we use grams. Kilogram, which is 1,000 grams, is used to measure things. It's a little more than 2 pounds. Liter is how we measure volume. You can see that different volumes we're measuring using the liter amount. A liter is a little more than a quart. Celsius is what we use to measure temperature. And 0 degrees Celsius is equivalent to 32 degrees Fahrenheit. And that's our freezing point. So as I mentioned, everything's based on 10. So we use a bunch of prefixes to help us denote multiples or parts of a base unit. You can see here, kilo, K, is 1,000 times the base unit. Hector, H, is 100 times the base unit. Deca, Da, Da, is 10 times the base unit. And then the base unit, whatever it might be. Then deci is 1/10 of a base unit. Centi is 1/100th of a base unit. And milli is 1/1000th of a base unit. If you want, you could pause the video and take a screenshot of this if you like. When we talk about changing units within the metric system, we go to change either to larger or smaller. If we have our base unit in the middle, we're going to either move to the left or to the right as far as our decimal movement. So to change from a small unit to a larger unit, from right to left, we're going to move the decimal to the left for each spot. So if I'm going from right to left, I'm going to move my decimal to the left for each spot. Change from a large unit to a smaller unit, left to right, move the decimal to the right for each spot. So it's going to keep moving to the right. As we talk about changing units, here are some examples. Converting 573.2 meters to kilometers. So we're going from small to large, smaller to larger. So what are we going to do? We should move the decimal 3 spots to the left. Small to large, 3 spots to the left. 1, 2, 3. Should be 0.5732 kilometers. Here, 14 grams to CG. Since we're moving to a smaller, grams is bigger than centigrams, we're moving to a smaller, big to small, we're going to move to the right. So 2 spots to the right, 1,400 centigrams. Convert 240 DL to DAL. So we are moving from small to big. So we're going to move left. Small to large, move left. 2 spots to the left, 2.4 deciliters. Here are some examples. These are from the text as well. The sign from New Zealand shows that the distance to Queenstown is 48 kilometers and the distance to Invercargill is 141 kilometers. Determine the distance to Queenstown in meters. We're going from big to small. Big to small. So we're going to move our decimals to the right. So 48,000 meters. And determine distance to Invercargill in decimeters. Decimeters. And this is where having that screenshot is going to be helpful. Maybe I'll take a picture of it from the slides and put that on the homework too. But we are going to move it over to the right quite a few. 1,410,000 decimeters. Example number 2. Arranging order from smallest to largest, the lengths 3.4 meters, 3,421 millimeters, and 104 centimeters. Well, to do that, we probably have to convert them all to the same measurement. In this instance, we probably want to go down to millimeters. So 3.4 meters converted is 3,400 millimeters. 3,421 millimeters is already converted, and 104 centimeters will convert to 1,040 millimeters. So in order, from smallest to largest, 104 centimeters, 3.4 meters, 3,421 millimeters. So this is a little introduction. Your homework is going to seem a little beefy, but that's because I want you to have opportunity to practice this. Practice makes better. And so 2 to 64 even. Lots of practice. Get a chance to really kind of dig in deep to this content. So I will see you guys in class.